remember the sample size 45. This is the notation, lowercase n, sample size, and we have 45. We have the minimum in the sample size 672 and the maximum 738. We want to group data in classes. So let's group the data in classes. But the question is, question number one, how many? How many classes? Well, let's look at what is called the range of this data set. By definition, the range of a data set is defined. So range is maximum minus minimum. So that is 738 minus 672. So what is the range? 6 and then 6 again. Right? Am I correct?
Yes.
Perfect. So the minimum is here, the maximum is here, and in between, so the minimum 672, the maximum 738, and this is 66. Okay, now, how many classes? That's kind of arbitrary, to be exact. So the number of classes is kind of arbitrary. But I would like to have a width of the class width, that is something convenient. Okay, so number of classes is normally between 5 and 20, arbitrary, depending on the data set. But I would like to think of the class width. So if I want to consider a class width of 10, then I will say, okay, I will have the range divided by the class width. So I will have approximately 7 classes. So number of classes is the range, number of class width. If I say the class width should be roughly about 10, or you can say, well, maybe I should start with a number of classes. Maybe I want 7 classes, and then I will consider that the class width has to be roughly 10. I don't have to start at 672. So please keep in mind a histogram. So we are trying to build a histogram, right? Number 2. The histogram does not have to start at the minimum, which in our case is 672. It does not. I would like it to start somewhere where it's convenient. I think it convenient is to start at 670. So I'm going to say this is my 670, this is my 680, they all have the same width, 690, this is 700, and I have to go to 738. This is 710, this is 720, 730, 740. What will I do next? Well, in order to start my histogram, first of all, I will start here with the first height, but I have to know how many I have between 60 and 670 and 670 and 680. So I have to determine the frequency table. I have to find the frequency distribution. So first between 670 and 680, between 680 and 690, and so on and so forth. Between 700 and, I'm sorry, no, I have to start with 690. I cannot miss any. So 690 to 700, and then 700 to 710, and 710 to 720, 720 to 730, and finally 730 to 740. So I have to determine the frequency for all. And then I will be able to finish or present the histogram and look at the distribution. Why am I doing this? Why am I summarizing the information, summarizing it in a frequency table and then in a histogram? Because I like to see the distribution. Maybe it looks like this. Maybe it looks like this. Maybe it looks like this. Maybe it looks like this, and we're going to talk about all these 4 possibilities. Okay, so that's my purpose right now. So I'm going to share my screen again, and let's go to StatCrunch. So I'm going to close this, and I want to see, go to row, I just want, I just wanted to sort. Yes, I want to sort. Don't do anything just yet, just give me 1 second. Sort, select the column in ascending. Yes, that's what I want. I only have 1 column. So go to sort, select the column, not all columns because I only have 1. Select in ascending from the smallest to the largest. That's also another way of determining minimum and maximum, obviously. I don't want to replace the column. No, I want the raw data as is. I want to create a new column. I don't want to open in a new table. No, I just want it to be the second variable. And compute. So now everything that I had in column 1, it's in column 2, and it's in ascending order, as expected from 672, obviously, to 738, as expected, from the minimum to the maximum. And now, let's identify how many we have between 670, how many observations we have between 670 and 680.
2.
So between 670 and 680, we have 2. Awesome. Great job. Got it. Next one. 680 to 690.
0.
Yes. Awesome. Great job. 690 to 700.
9. Wait.
So 1, 2, 3, 4, 5, 6, 7, 8.
8.
I counted.
I said 8.
2, 4, 6. I see 9. Am I correct? 1, 2, 3, 4, 5, 6, 7, 8, 9. I
Yeah,
see
I
9.
got 9.
Okay. From 700 to 710. 1, 2, 3, 4, 5, 6, 7. Yep. Then from 710 to 720, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, moving on to 21. 21, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Good. So then the last one.
6.
1, 2, 3, 4, 5, 6. Now I'm checking and make sure that all these numbers add up to
45.
45. If they don't, we are in trouble. So 11 plus 11 is 22, 32, 39, 45 indeed. Okay, I will stop sharing for a second. Let's do this by hand. So then if this is a frequency histogram, I know that the highest is 11. So I'm going to say 2, 4, 6, 8, 10, 12. So this is 2. The next one is 0. The next one is 9, 2, 4, 6, 2, 4, 6, 8, 10. So it's 9 right here. Then the next one is 7. 7. The next one is 10. The next one is 11. And the last one is 6. 2, 4, 6. What kind of distribution is this? According to my graph, I wouldn't say that I would say, first of all, that it has some sort of a tail on this side. I wouldn't say that it's a symmetric distribution that much. They are kind of close to each other except the 2 and the 6 and the 0. So you could say a little bit skewed to the left. It has a longer tail to the left. I wouldn't make a conclusion that is just any. I would say, well, maybe we have to look at more data than just 45 to draw a conclusion. Maybe I have to change the number of classes. Maybe if I have 5 classes, or maybe I should look at 10 classes. Right now, I cannot make a big decision or decision that stands. I will look at 10 classes, change this. So if I have 10 classes, then the class width would be smaller, narrower. I will look at maybe 10 classes, maybe, as I said, or 5, and compare. But right now, that's what I have. I'm going to share my screen and go back. Okay, so graph, and let's try the histogram this time. And it doesn't matter which one you use. We can use the sorted eruptions or not. Number of eruptions, it doesn't matter. Group by, okay, I want the frequency. Yes, I want the frequency. Start at, I would like it to start at 670, although it can be optional. I would like the width to be 10. And yes, you can put the information here, the x-axis, that would be nice. I would say number of eruptions. Oops. I would say frequency here. And the title, it's a histogram for eruptions. I should be more detailed. I would say for such and such Wyoming geyser, etc., just to make it as nice as possible. And then go to compute. And this is what we see. It did not consider, it took the 700 and the ones that were on the edge, it considered them to the second one, which is fine. I agree with it. So 700 should not be included. That's fine. It could or it could not. So that's what StatCrunch is doing it. And I agree with it. So the ones on the edge will go to the next. So the 700 will go to the next. 710 will go to the next, which is correct. That's fine. So as you see, I can't say much about it. I can go back and look at the data set and change the number of classes. So I'll go back to the histogram, and this time everything is the same. I click the same. I will not label it and take your time for that, but I will change the width and make it wider. So let's say we want to still start at 670. Oops. I still want 670. And I want the width, instead of a class width of 10, let's make it smaller, like class width of 5. And let's see how it looks right now. Okay, so that's why I'm having difficulties in drawing a conclusion about the distribution. And it showed that from the very beginning. It was not a clear-cut shape. Now I can go back and look at one more histogram in which I put still the starting point at 670, but this time I would like it to, we went to 5, let's go to 15 this time. And let's see what happens. Sorry. Got it. Well, this is a much nicer histogram. Here, in this particular case, I could say that is kind of a little bit skewed, a longer tail to the left, skewed to the left, but it has a better shape than the other two. So that's how researchers look at data. They look at different situations, at different histograms, different number of classes, different class width. So the minimum for this class is 70. The maximum is 685. But the class width is determined always by the range of the data set divided by the number of classes. Okay. Any questions so far? Okay, I know I have 15 minutes left. Do you want to start? What I wanted to do next